Hello, I'm Ian Coley, the General Manager of High Performance Computing at AWS, here to talk to you about our latest services and offerings. Here at AWS, we have a number of services to support you on your HPC journey to the cloud. From data management and data transfer via AWS Data Sync and AWS Direct Connect, our compute and network offering with a variety of Amazon EC2 instances, giving you the latest in CPU, GPU, and FPGA technologies. And I'll go into further details on the specifics of the instances we have offering at this time. For advanced networking, we have our enhanced network adapter, as well as specifically for high performance computing workloads, our elastic fabric adapter, which provides a low latency, low jitter interconnect. For storage, we have our Amazon Elastic Block Storage, our Amazon EFS, and Amazon S3 Object Storage, as well as a popular Lustre offering, Amazon FSx for Lustre. For automation and orchestration, we provide AWS Batch, our cloud-native batch scheduler, as well as AWS ParallelCluster for cloud orchestration and NICE Engine Frame. For remote visualization, we power NICE DCV, which is underlying Amazon AppStream 2.0. So let's go into a little bit more detail about AWS Batch. AWS Batch dynamically provisions compute resources based on the volume and requirements of submitted jobs. It will plan, schedule, and execute your batch jobs across resources. There's no batch computing software to install, allowing you to focus on your applications and results. AWS ParallelCluster provides you easy cluster orchestration. It's fully integrated with standard on-prem schedulers, as well as AWS Batch. It allows you to launch Amazon FSx for Lustre, and it utilizes our Elastic Fabric adapter. But at the core of any HPC offering are instances. As you can see at Amazon, we have over 275 different instance types. Those are a mix of storage intensive, GPU compute, compute intensive, general purpose, fast processors, high memory, advanced networking, and bare metal. We allow you to select the options that you would like to provide the instance that is most suitable to your high performance workloads. But what does that mean for HPC users? Out of these 275, there are some that have become the de facto standard and the workhorses of our HPC organization. First of all, is our high bandwidth compute instance P3DN. This is optimized for distributed machine learning training. It's based on NVIDIA's Tesla V100 with 32 gigs of memory. You can have up to 8 GPUs. This comes standard with 256 gigabytes of GPU memory, 96 vCPUs, and a total of 768 gigs of memory. This allows you to perform distributed machine learning training across multiple instances. And as with all of our enhanced network instances, which have the N on the suffix, they come with 100 gigs of network throughput. Now on the compute side, our standard instance that has been popular with HPC workloads is the C5N, giving you that 100 gigs network bandwidth, standard with that N on the end of the instance name. You get up to 72 3.5 gigahertz vCPUs and up to 192 gigs of memory. Now what you'll notice with the C5N performance is a vast improvement with C5N's 100 gig networking because of the also combination of the Elastic Fabric adapter. The Elastic Fabric adapter and C5N allow your HPC workloads to scale beyond typical scaling requirements of HPC. But it's not just the P3DN and C5N. As I discussed before, we have over 275 different instance types with a mix and match of various GPUs and chip manufacturers. We support both Intel, AMD, and now most significantly, our new AWS Graviton processor. AWS Graviton is custom AWS silicon built upon the 64-bit ARM Neoverse. It's built specifically for your cloud-native workloads. And it's built with the underlying Amazon technology you've come to expect from us, specifically built upon Annapurna Labs. But how do we take those ARM instances and put them into the configurations that you would like for your HPC workloads? As you see, some of our most favorable instance types for HPC customers are M, C, and R. Now the nomenclature here is the generation is the number, and the G on the end is for Graviton. So here we have the M6G, which is now generally available, and C6G and R6G, which will be available shortly. Now those are various combinations of memory and CPU in the ratios that you've come to expect to perform your most demanding workloads. And here are the instances available right now on Graviton processors. We have the M6G Medium with a single vCPU and 4 gigs of memory, network bandwidth up to 10 gigs, all the way up to the M6G.16 Extra Large, which has 64 vCPUs and 256 gigs of memory with 25 gig of network bandwidth. Now we also offer that instance in a metal offering for those customers whose workloads would take advantage of that. Now, as you noticed with that M offering, it's approximately 4 gigs to 1 CPU ratio. When the C and the R come out, the C will be approximately 2 to 1, and the R will be approximately 8 to 1 memory to vCPU. But what does that give you for your actual workload performance? Now, while it depends on the specific benchmark that your application runs as, we advise you to fully take advantage of looking at how an M6G performs right now versus the current M5 and M5A instances. Here we see results from SpecInt 2017, NGINX, and Memcached. SpecInt's 2017 has been around for a few years now, so we've been focusing on that to identify our performance. It's CPU intensive, includes a wide variety of benchmarks from Perl, compiling code with GCC, route planning, discrete event simulation, XML to HTML conversion, and others. Here we have an estimated run showing up to 44% faster per vCPU than M5. And the M6G instances are 20% lower cost as well. Next, we have NGINX, a popular web server and load balancer. Using work to simulate 512 clients with small requests to stress the system, targeting 4 backend servers in a placement group, we've seen M6G instances deliver up to 25% more requests per second relative to the equivalent M5 instances. And finally, we have Memcached. This is a popular key value store used to look up data faster than traditional databases to improve application responsiveness. Using 16-byte keys and 128-byte values with 2 load generators generating 576 connections, we measured M6G instances providing 43% higher requests per second relative to the equivalent M5 instances. But it's not just about performance. It's about performance per price. And how does that price per performance compare for you? So we encourage you to look at the lower TCO you can achieve with Graviton 2. M6G offers 20% lower cost versus M5, and in some cases up to 40% better price performance. But as we look at orchestrating any system, it's not just the instances that form the system. It's a combination of instances, network, and storage. Now with HPC on AWS, we support the Elastic Block Store, the Elastic File System, and Amazon S3 Object Storage. But one of the most popular offerings we've found for our HPC customers has been Amazon FSx for Lustre, our fully managed HPC shared file system. You get 100 gig per second throughput, millions of IOPS, and consistent low latencies. It provides a fully managed Lustre file system that allows file-based applications to access hundreds of gigs per second of data at sub-millisecond latencies. Now, most of you know the Lustre is a popular open source parallel file system designed for these types of compute-intensive workloads. These include not only our standard HPC workloads, but also distributed machine learning and media and entertainment processing. This parallel file system supports the high bandwidth required to handle the high throughput and process massive amounts of data and perform operations at low latencies. It does so by storing data across multiple network servers to facilitate high performance access through simultaneous coordinated input-output operations. The Lustre file system provides a POSIX compliant file system interface and hundreds of gigs of second of throughput. It can scale to thousands of clients and supports some of the Earth's most powerful supercomputers. As you can see, we've crafted this system to be performant just for you, not just with compute and not just with file. This provides 200 megabits per second of file system throughput at approximately 5,000 IOPS, backed directly by SSD-based storage. So you get the POSIX compliance you need, the fast SSD storage you expect, and you can back it by thousands of cores to feed those hungry interfaces. Now let's take a look at what our overall system looks like on AWS. There we have the data transfer, whether by Amazon Glacier or Amazon S3, as well as third-party providers. We connect that into our VPC on AWS, where you've got the shared file storage with Amazon FSx for Lustre. We operate on that storage with our HPC clusters, built using AWS ParallelCluster for orchestration and scheduling jobs via AWS Batch. Here we meet your network, your storage, your IO requirements, all in AWS for high performance computing. But many customers have very stringent requirements for their HPC workloads. These are some of their most sophisticated data. And these are just some of the compliances at AWS that can enable the most security conscious customers to run workloads. We're continually working with customers to determine if there are additional compliances that we can obtain. But as you can see, we have some of the most demanding that are standard throughout the HPC industry. From NIST to FISMA to ITAR and FedRAMP. Our HPC workloads are standard across industries. We have customers like AstraZeneca performing complex genomic sequencing in the life sciences arena. We have FINRA and Financial Services performing their end-of-day calculations. We have British Petroleum in oil and gas, and an autonomous vehicle, Drive.ai. And then one of my personal favorites, the Weather Company, Climate and Geosciences, helping you predict the next weather patterns in your area, as well as Autodesk performing design and engineering. But we can handle all sorts of types of workloads as well as different industries. From accelerated computing, AI ML, tightly coupled workloads, or complex visualization for media and entertainment. My personal favorite on this slide is Formula One there, helping to design the most innovative next generation standard of race cars. But we at AWS don't do it alone. It takes a broad partner community for us to provide you what you need to be successful with your HPC workloads. From software vendors like Ansys and Siemens, to our infrastructure partners, Univa, and IBM, as well as our technology partners at Intel and NVIDIA. But then kind of the backbone of many of our customer successes have been our partners like Rescale, 6ix9ine, and Ronin, helping our customers develop solutions that work best for them. But I'd like to end with a personal favorite story. Now, there have been many reports lately of some instances of running top 500 runs in the cloud. But what I find so intriguing about this specific run is this is a run done by a customer of ours, Descartes Labs, and we didn't even know it happened. There was no coordination between the customer and us. This was purely them saying, hey, we'd like to see where we could get on the top 500, just spinning up spot instances on AWS. So what you can see here is they were able to run 41,472 Skylake processors for a total cost of around $5,000, and they wound up at number 136 on the top 500. Now that's an accomplishment to me. This was a customer that was able to elastically define the compute that they required for this run, use it, and then shut it down, experiencing the elasticity and the cost savings that we expect from cloud resources. Now I'd like to leave you with this. If you're interested in finding out more about defining your own HPC cluster on AWS, please go to aws.amazon.com/getting-started/projects/deploy-elastic-hpc-cluster. Or just go to aws.com/hpc and you'll find more information. Thank you for your time. Have a great rest of your virtual show.